Can someone summarize it? What we did in last class?
So we learned about different models in like machine learning.
We didn't learn about models.
So like different type of like machine learning. uh, Okay, so different type of problems.
Okay, you're halfway through, correct? So we're seeing like different methods how to solve any machine learning problems.
Yeah, sir.
Okay. So can anyone tell me what supervised learning is?
So like using the data, like it predicts the outcomes.
Explain little bit more because everywhere you use the data, so it's not clear.
So like it would know like what kind of data it will be like. I don't know how to put in words.
Okay.
Supervised learning.
I gave you example of oranges and apple and those kind of things. You remember?
Yeah, sir.
Okay. So what was written below those images?
So like you mean the name or like it would know the category.
So supervised learning is nothing about the data you already know. You're trying to classify the data according to that one. If you give new kind of data.
Yeah, sir.
Okay, fine. So there were two more, right?
Yeah, sir.
Three more, yeah. I'll give
Like
chance to, I'll just give chance to others.
okay.
Mm, Maria, Maria is there,
Yes,
right?
the next one, unsupervised learning, is when like a set of data is given and the model tries to find out patterns in within the data and to like classify it according to the pattern that it found.
Okay. Once again, what kind of data?
Unlabeled data.
Unlabeled data. Okay, that is true. So here we don't know what the data is, but we are trying to classify and predict by learning the patterns. Okay. So other person reinforcement learning.
So can I?
Yeah, sure.
Yes, sir. So reinforcement learning is kind of like when I get the data, when I face errors and some kind of problem, it's like going, running and running, correcting and correcting itself, and running the code again and again through trials and getting its goal.
Okay, so what you're doing in reinforcement learning is that you're trying to learn from your failures. So it's not just the failures. It's like you're getting new set of data, getting the pattern from that one, trying to learn the error and correcting that one. Okay. Semi-supervised learning.
Can I, can I say, sir?
Yeah, sure.
Yeah. Like semi-supervised learning is like that uses a small amount of labeled data, and along with that, it also uses large amount of unlabeled data to train a model.
You told is absolutely correct. So here we knew some of the data and some of the data is unknown. So then what we do is like we'll try to learn from those set of data in machine learning methods. Okay. So in supervised learning, we went through different types, right? So can anyone tell me one by one what this is? Yeah, Ruben, can you answer this one? Is he online? Ruben is online. Okay. Sipinath, you can answer this one.
Excuse me, sir.
Yeah, Ruben.
Sorry, sir. I had some audio issues.
Okay. So, like different types of supervised learning, like we went through, right? So, can you explain one by one, like what these are?
Okay, sir. So the first one is classification. So it is like we give two or something like the we classify into like two sections. So it's like saying which one it's more likely. So it's like saying, so for, in the examples, we can say that email spam detection. So there will be, it'll check whether it is more likely a spam or it is if whether it is more likely or not a spam.
So, if you give image recognition example.
Image recognition. So like if for example, if there's like an image of a cat and it is saying that it looks like a dog, then we correct it by saying it looks like a cat. So then it corrects itself and by changing the equation.
Internal process it will do. You don't have to worry about. But I'm just
Yes,
asking.
sir.
So, what you told is
Yes.
true. So, there will be these labels or categories. So, based on that one, you'll just try to classify. Just try to fit them like which it most probably fit into.
Yes, sir.
Can you tell about regression?
Regression is not for like two like specific values. It's like it takes a continuous values and it predicts what might come next. This is like it's not a single like two individual values. It's like continuous uh, like in graphs. So it predicts what the next value might be.
So true. Like what you told is correct. And
Yes,
then
sir.
Sibinath, time series forecasting and ranking.
Sir, as I said earlier, I couldn't attend last class, and due to my exams, I couldn't watch those recorded videos as well.
Fine. Oh yeah, you just messaged me. Fine. Okay.
Yes.
Anyone time series forecasting and ranking? Can you just little bit explain about that?
So may I?
Yeah, sure.
So time series forecasting is like based on the intervals where like from the data that we give, it will predict when the next uh, like instance of occurrence will be.
Okay,
Uh,
that is correct.
and ranking with it does not give a actual value as an output, but instead classifies it into like different categories, like ranks it.
Okay, that is correct. So in ranking, like what we do is like, so whether he was first, second, or third, like we are trying to give some preferences. So that is what we are trying to do in ranking. So this has to go first, second, third. So in order it has to go, right? So that order we are trying to uh, learn from the AI model. Okay. So we did till neural networks, right? So this is one of the key concept. This also can someone summarize at ANN, CNN, RNNs. Did we do this one? Neural networks last class. Anyone can summarize this one, neural networks. We did it. We did this in last class.
So first two I can.
Yeah, sure.
So like artificial neural networks, just like human neurons, like we'll have hidden layers. So where we like where the data will be like processed. And convolutional neural networks, it's for image generation.
particularly for image generation. So those would be having like as I told, matrix multiplication and those kind of things. Like we call them as convolution. So we'll use it to derive the uh, edges and mostly the lines. Will try to get the patterns. So I've explained to you like how the cat and dog knows and those kind of things, like how it will try to
Oh, yeah,
detect, right?
sir.
So that is where we use convolutional neural networks in order to get the patterns of the images. So RNN and transformers, anyone?
So RNN, I'm not sure, but I think it's like it will keep the memory of the previous training, or like uh, from each layer, like the output from each layer will be carried on to the next one. Um,
That is correct. So in RSTN, what it does is like RSTN, LSTM, or GRU, right? So other models are sequential. So if you pass your input, it will just directly go to your output. So in RNN, what happens is that even in some hidden layers, not in some, in all the hidden layers, you'll be having the memory in order to keep the data. And if you want it, you can send it back in from the particular hidden layer once again, and you can just train it back. Okay, transformers.
So can I?
Yeah, sure.
Yes, sir. Transformers are kind of a neural network which is made for processing language and sequence of machines. How machines process language and sequence?
Okay, so this once again, in English, lexicons and those kind of grammars, everything, right? So those are all like continuous data. So this sequential data would be passed through the transformers itself. So it will try to understand each and everything which you send. It will try to give you the output according to that one. Okay, so we'll continue with unsupervised learning methods. So I'm just explaining you like what are the different problems you'll be facing in future and how you can get equipped with that one. So for that reason, I'm explaining all this problem statement, because in AI you can't simply use just one neural network and you can just get the output properly. So you have to use all the things. You have to combine most of the things in order to get your outputs the desired way you want. Okay. So I'll just ask you one question. So in ChatGPT, like if you ask something which is known to it, so how will it respond? For example, one of the students' daily activities, I'll ask, will it know?
No, sir, like it would ask to like give the data, then like
So till now, like what we studied was that we know the data, we try to do some learning in the machine, and we'll try to give the output accordingly. But what if there is unknown data? So how do you, like, I'll just ask in general, not from machine learning perspective. So each one of you, I'll ask you. So if something data is not known or something information is not known to you, right? So if I ask something about that, how would you respond?
so that we don't know.
Okay.
then like we would try to know it like that time, like we try to.
Okay. So first one, you don't know. That was the first step. Second thing, you'll try to learn. Okay. Third step,
So maybe try to relate it with the things we know, if it is possible.
assumption. So that is third part. So
Yes, sir.
assumptions you can do. Anything else?
So like trying to guess what we know, like at like not the whole thing, but maybe just a bit information which we already have about it.
Okay. We'll consider it as step three itself. Assumption, guessing, and kind of predicting like what is unknown. Okay. Next step.
Maybe we'll ask them to confirm if that is what they're looking for, like if that's the answer.
Okay. So you're trying to get the feedback. So whether it's true or not. Okay, fine. Anything else? Okay, I'll ask you one question. Okay. Let's just say you're in your eighth standard or something like that. You'd be dividing your whole year into trimester or semester, 2 or 3.
I mean semesters, like
Okay,
at school.
semester. Okay, in your school semesters. Okay, so till October one session, and after that one
So
more.
like there'll be two.
Two. Okay, fine. So semester wise, right? Okay. And so semester wise, like what you do is like instead of taking everything as one, like I'll divide it into two things, right? So in K means clustering also, it will try to do the same thing. It will try to divide. So when you give some data, right? So it's easier if I show you some images here. Okay. So if something is not known, right? For example, this one I take. So this complete data is not known to the machine learning. So the best appropriate way, what it can do is like it will look into the data. So if you see over here, like based on the coloring, right? So try to segregate. So there is group of data over here. So there is some group of data over here and some group of data over here. And it tried to make the color combination over here. So it will labeling. So color combination is nothing but labeling. So any guess you can make like what it is trying to do? So this is the graph, x-axis, y-axis. So there are some data points. So it tried to draw a circle. So mathematically, if you think logically, can anyone answer this one?
So is it like a function like within this range to this range, like the output value will be like let's say like below 3 or uh, like after
No, we
that
won't specify. We
near
won't
that.
specify anything. So without specifying, like it will try to classify, right? So logically, you think what is happening?
Is it finding like similarity or like nearby?
Nearby, you told, right? So can you put it in mathematical terms? Nearby is correct. So in
Like
order to calculate nearby,
it's grouping.
it's grouping. Like in order to
Uh,
group, right?
so is it
So
finding variation in cluster?
like if I give this example, I told you, right? So this is the graph. So x value and y value. So there are some data points. So it told range is correct. One thing, range is correct. And then it is trying to group, right? So there you'll do some mathematical equation. So I'm asking for that particular one. So you'll do four things, right? In mean, median, mode, minimum, and maximum. So you remember those minimum, maximum, mean, mode, variance, and
Yeah,
those kind of things.
Yes, sir.
Is it
So
dividing into equal parts?
it won't divide into equal parts based on this calculation, right? So mean and mode. So mode is nothing but how much times the data is repeated or something like that. And mean is like average. It will try to take and of all the data, and it will try to do that one. So minimum value, maximum value, it will try to calculate. So based on some statistical method. So K means it will try to group the things. So that is what it's happening. So more specifically, like if you want to look into this one, some line it is trying to draw, and then it will try to group. So this, whatever it does, right? So it will automatically run from the data without the labels. and it will try to give the outputs based on that one. So it doesn't like they're giving that color because they're trying to in order to make you understand it's different kinds of data, but it's already grouping. For that reason, they give you that color. So it's just actual some data values. So in order for you to understand, they just made it into colors. So K-means clustering also does the same thing. It will try to partition your data into groups, so into clusters. So nearest values or something like that. So it will try to look into that patterns, and it will try to classify or do prediction or something like that. It will try to do.
Excuse me, sir.
Yeah.
So what kind of data will you try to classify? Where will I actually use it?
Sorry, there was some background noise. Can you repeat?
So what sort of data will we use by this method? To classify?
So it will be numerical data itself most of the time.
Okay, sir.
So when you go into statistics, right? So it will be numerical data. Okay. For example, let's just say I want to buy some land in Bangalore. The same thing if I want to buy in Arkalgod, if I want to buy in Mysore, it would be ranging, right? So different, it would be trying to range. The cost of the range would be differing, right? So in Bangalore, it will cost more. In Mysore, it will be less. In Arkalgod, it will be still way lesser. So these data, like someone would be having already, or they would have, based on the place, they would have updated. So these are like numerical data everywhere. So if you want to decide on something like that, you'll just give like, these are my conditions. So you want to just classify and give it to me. So you'll just give some range, right? So if I want to buy it for 50,000 or 1 lakh, so based on that, it will try to give you some outputs. So most probably it will be numerical data.
Okay, sir.
Okay. Next is hierarchical clustering. Mm. So last time we saw decision tree, right? So can anyone explain decision tree? So we gave one example last class, decision tree.
Sir, it's like a flow chart.
It's not a flow chart. Decision tree, I told you, right? What is decision tree last class? Or else
Yes,
I
sir.
gave you. Yeah, tell me.
Sir, it is like a series of conditions. So according to the results, it like goes up or down the decision tree.
What you told is true. So based on the condition, whether it's satisfied, right? So based on that one, you'll try to go through the next stage. For example, I gave you one example related to a student, whether is he from, okay, I gave it for neural network, right? Okay. For example, like we'll try to see the student whether he's from class 3 or not. So you'll be having different criteria, right? His height, ID card, everything. We'll try to check that one. So here also we can use decision tree for that one. Okay. In clustering, right? So here also, like most of the things would be, it would be like numerical data itself. Okay. Have you guys have experience working on sensors like temperature sensor or humidity sensors in your school or somewhere you have used?
So like we didn't use it, but like I've heard about like and I just know how they work.
Okay. So in sensors, right? Or else everyone has smartphone, right? The smartphone you have. Okay, we'll
Yeah.
do
Yes,
an
sir.
experiment in next class. We'll do in next class. So we'll try to take some data and we'll check that one. So it would be like real time. Do that. Okay. So IoT, like have you heard IoT? Internet of Things.
Uh, yes, sir. Heard of.
Yes, sir.
Okay. So what they do is like, for example, I'll give you. So IoT in agriculture, I'll give you. In field, what they do is like they'll put some humidity sensor, then temperature sensor, and they'll try to measure everything. For example, at 9 o'clock, this is the temperature and whether the soil is wet or not. So using that, they'll check for the humidity. So continuously, they do it throughout the day with equal interval. So at particular points, the temperature changes, right? For example, let's just take. So this is throughout the day. Okay. For 9 a.m., let's just say the temperature is, I'll just take it in single digit, so it won't be the actual case. 9 a.m., it's 7 degrees. Then at 10 a.m., became 8 degrees. So then 11 o'clock, 9 degrees. 12 o'clock, it became around 11 degrees. So on. So it will go. Again, like there will be decrease, right? So at 4 o'clock, it will try to reduce once again. I'll take it as 11. 5 o'clock, it will become 10 degrees, something like that. So same sensor data throughout the day if you try to get, right. So temperature, it changes from morning to evening. So what we do is like continuous data, which I told you, right, regression or something like that. So for the same values or same sensor or some ID or something like that. So these different values should be using. So in order to, it's the same thing, it's the temperature. So then some columns, it will be easy for you to understand. So, okay. So this is some ID. So this is some sensor and this is some temperature. So ID would be 1, 2 or something like that, 3. So sensor 1, this is sensor 1, sensor 2. So temperature is about 7 and then 8. And then somewhere in sensor 2, one more sensor would be there. So that temperature would come around 8 or something like that. So even though like it's different sensors, right, you're just trying to get the temperature. So what you do is like I'll try to do this hierarchical graph. So at that particular time, for example, okay, I'll just a different way. Sensor 1, sensor 2, and sensor 3. Temperature was 7, 8, and 7. So what I did over here is that, so in a field, they'll try to place 3 different sensors. So temperature sensor 1, 2, and 3. So at that particular times, so for example, at 8 o'clock, they wanted to check the temperature. From 3, it was 787. And at this one was 9 o'clock, right? So at 9 o'clock, so this changes 8, then let's just say 9 and 8, something like that. So even though it's the same temperature at different places, right? So what we do is like same time. So sorry. So one same time we'll try to consider, and we'll just try to give different sensors, sensor 1, sensor 2. We'll try to group that one accordingly, and we'll just have the value at the below. So this is hierarchical clustering. So this is similar to your decision tree, But the data is what you have is like it will be at the bottom. We'll try to group that one. For example, so this is the agriculture. First layer is agriculture. So then place 1, place 2, place 3, and place 4. Then sensor 1, sensor 2, like this. 3, 4, 1, 2, 3, 4. Like they'll try to have the hierarchy of the decision tree, and then they'll have the values. So this one I recently came across like while trying to do some prediction. So I thought I'll explain it to you. So whenever you're trying to do some prediction, right? So without unknown data, so keep in mind. So this will come in handy. This hierarchical clustering and your regression problems. So they both go well for unknown data prediction or something like that. Okay, I'll just ask one question. How good are you in maths, everyone? So this
So,
when you come to yeah,
so you mean like academically like
no,
fine but not like a genius or something.
I won't consider academically. Academically, like they'll teach you the basic, but when you try to want to understand a problem using mathematically, how good are you?
So I don't like I'm fine, not too good. Like I didn't experience out of like academics.
So what about others? Okay, so you're not sure like how good you are in maths. Others, you're not that confident. Even if you're bad, it's fine. It doesn't matter.
Sir, I think I'm okay, but then again, as Sanishka said, I don't think I've encountered a situation where, like outside academics, I had to use math.
Okay. So maths is nothing but like how you represent things and how you solve. So you use maths everywhere. Don't take it like literal word, literal mathematics, like using complex equation, using some those kind of things. Like if something is given to you, right? How do you understand that logic? How good are you? So in coming into AI or machine learning, right? So you have to think outside the box, like something like that, or it's not outside the box. Like you have to put some logic, try to make it understand. First, you need to understand what that is, and then you have to tell the machine. So try to learn this way and try to predict or give the classification of whatever you're doing. So that is what I wanted. So whenever you get time, right? So what you do is like uh, try to learn new things, try to understand. That is what I'll tell you. Because CA is not going just particularly into what is that image classification or something like that. So further, it will go into all domains now. So you just have to put some logic. You have to understand. If you understand, you make the machine to understand it, and it will try to learn. First, try to solve in your way, then give it for machine to learn. Is that fine? Like, did it make any sense? Like what I told?
Yes.
Okay. So I asked maths because so when you come to machine learning, right? So at the end, it's either true or false. So in order to come to true or false, you have to have some logic. So maths you'll use. So that's why I asked.
So,
Yeah.
so like, what is the criteria for it? Like, how can I know if I'm decent enough in maths for, or if I'm ready in maths for AI?
There is no such thing as criteria. So if you come to machine learning, right? So there is n number of ways. It's not just one path you'll follow. You can follow in any path, but if you land in the correct goal at end of your path, so then you're well and good. You can walk like 1,000 paths, no issues, but you have to reach the goal. That's all.
Okay,
So
sir.
one thing I can tell you, be good in your basics. So what I told, right? So that is why I asked minimum, maximum, mean, mode, standard deviation. So those kind of things like you'll feel now, so it is boring or something like that, you won't understand. So once you have this kind of data, right, working in future, like once you have this data, it makes sense why we are learning. That's all. So whatever you learn it in a way that you understand it properly, implement it in the place where you can implement.
Okay, sir.
Okay. Okay, we'll go into other things. So there is DB scan also, PCA, like these are like statistical methods itself. So we're just trying to do some grouping, classification, and those kind of things. This will come into more focus auto encoders, right? So these are also like different kinds of neural networks. So whenever you have some less number of datas, so from that less number of datas, like it will try to get the features. For example, I can give you in order to classify two images, I'll give you. So dog and humans. So I'll just give image of eyes. So from that it will try to classify, right, whether dog or humans. So that is where autoencoders like can come in handy. Like even with some little bit of data or very much less data, you can try to predict, but it won't be the complete one. Sometimes it can mismatch or something like that. So that is one thing. Autoencoders is also important ones. So we go into more classifiers. So as I told, this unsupervised learning is there, right? So it will mostly dependent on statistical problem statements. So this is like a probabilistic. So anyone heard of probability?
Yes, sir.
Okay. Can you tell what is probability?
The chance of an event occurring from 0 to 1.
Okay. So what it told is true. Probability is nothing but what's the chance of an event occurring. Event is nothing but in your class they would have told you about heads and tails. So that is the basic simple one, right? So it is nothing but true. Tails is nothing but false. So if I throw a coin toss, so what's the probability of that event happening? So that is what probability is. So what's the chance of it? Like if I try it for 3 times, okay, I'll just give you 1 time. So what's the probability that it will fall?
0.5.
Okay, so it's 50%. So there are two cases, right? Heads and tails. So if I do it once, so either heads can fall once or tails can fall, right? So if I do it for 2 times, either 2 times head can fall, head tail, tail head, and tail tail. So four probabilities can happen. Four possibilities can happen. So that is what you do in probability. So here also like what you do is like based on the number of chances you try to classify. So this is also statistical one. So I won't go into more details because it will go into more mathematical equations. So but try to think a base classifier, like it's like a probabilistic classifier. It will try to classify based on the number of events or whatever it's trying to recurring. For example, I just gave you the sensor data, right? So for day one, I got 7 degrees at sensor one. For day two, day three, or day four, we are trying to see the possibilities, whether it can happen in day 3, day 4, or something like that. So using naive Bayes, we can do that one. If you have large amount of data, so we can try to predict, not that accurate, but up to some extent. For example, I gave you this one, right? So find new. So I'll consider it as day 1, day 2, day 3, day 4, day 5, day 6, day 7. Okay, 7 days I'll take. So at 7 o'clock, I need some sensor data. So it was 6 degree and it was 6.5 degree. So then 7. So 7.5. So can anyone tell me what's the trend going on?
So like 0.5 difference.
Okay. So one thing is that zero point 0.5 is decreasing every day. So it might increasing. And in future it might become 8. It can predict that way. Okay. So let's just say for day 5, it became 7 once again. And then it rose to 7.5. Okay. So you're seeing the trend, right? So in day-to-day life, not everything is constant. So we try to predict it. So if you have used that normal mathematical method, so that is mode, right? Not mode. That is mean. We are taking 0.5 difference and we're trying to add. So next time we try to predict 8. So but in actual case, it came 7. So that is where this naive-Bayes classifier can come into handy. So if I have some data over here, right? So 7.57, it came. So some other data, for example, uh, let's just say, mm, this is day 4, right? So let's just say 6.5, 6 came in this day. So using all this data, right? So using those probabilistic method, you can up to some extent, instead of giving the complete wrong prediction, you can try to predict. So what is happening? So just understand. I'll just like as we go into more hands-on session, right? So you'll get to know like why this is happening. Just try to understand the logic. That's it. Okay. Then we have reinforcement learning. As I told, reinforcement learning is nothing but okay. So how many of you did experiment in your school, in your lab or something like that?
I have done
Okay.
some.
Okay. So what experiment did you do?
Like in various subjects like physics, chemistry.
Okay. Well, coming to chemistry, what did you do?
So like titration, salt analysis.
Okay. So in iteration, I'll come into that one. So every step, what were you doing? You would have a
So
solution, right?
yes,
2 solutions you'd be having. So in the 2 solution, what did you do?
we find out the point of like when it becomes neutral, neutralization point, and find out how much volume of one liquid was used.
So you're doing that one. So what was the first thing you did?
So like get the equipment ready and then get a reading.
Okay. Okay. By drop, like you told, volume should be dropped, right? So into your solution.
Yes, sir.
So what did you do? Like you incremented in some ratio, not ratio, some difference, right? So only like particular, let's just say you had 20 ml. So you kept on 1 ml, 1 ml at a time, right? So you were doing the titration every time, experimenting. So you didn't pour
So
everything. You didn't know at what point the color solution of the changed, right? So the color of the second solution changed. So what you did step by step. First step, like you gave 1 ml, 2 ml, 3 ml. So let's just say at 7 ml, uh, the color of the second solution got changed. So that is what you are doing the experiment, right?
yes, sir.
Okay. So I like exactly I don't know 7 ml I have to put. So then I don't know, right? So for that reason, what reinforcement learning also does is that so it doesn't know the exact goal. So it will try all the experiments and it will try to reach the goal. Anyone has did any other experiment?
Yes, sir.
Okay. So what is that, Kanishka? What experiment?
Like classifying acids and bases, and I did titration too.
Okay. So we also done that. Okay, fine. So in physics, what experiments did you do?
Like about the lenses, like convex and concave lenses.
So concave and convex. So what did you try to find over there?
Like the focal length.
Okay, focal length you're trying to do. Like what are the steps you followed?
Like we would keep the lens and then move the like screen like to get the image in the screen.
Okay. So during that steps, how many times you had to move?
So sorry, it's not lens, it's mirror. Can you
Okay.
repeat the question?
That mirror light in order to get the proper image. So how many times you had to move?
So move like
Uh, okay. So uh, can you elaborate a little bit like what you did that experiment?
uh, we had the mirror and then after reflection, like to get the image on the screen, I would like we would move the screen to get the image, like to catch the image on the screen.
Okay. In order to capture the image, you told you're moving that image, right? Image are you moving or what you're
So
moving by the.
screen, we moved the screen.
Okay, you're moving the screen. So how many times you had to move the screen? So if you do it in the first time, will you get that one?
No, sir.
Okay, so you have to go left, you have to go right, you have to adjust it, right?
Oh, yes.
So here also same thing it's happening. In reinforcement learning also, it doesn't get to the goal at the first time itself. So it will move left, it will move right, it will come in middle, it will move little bit right or something like that. It will keep on repeating until it satisfies and whether it has reached the goal or not. So there are many popular algorithms. Mm, so Q learning, deep Q networks, policy gradients. So don't worry about this and all. You won't go into reinforcement learning. But when you're into robotics, right? So that is where these all models or these all uh, things come into handy. Where the AI, where we use reinforcement learning. Uh, in last class, I told you about this competition where they were trying to land a drone. They gave the competition to some of the students so that to land a drone. So they made a simulation of Mars terrain. So one, two, three stages were there. You had to land your drone on that one and come back. So that is where reinforcement learning was used in real case application. So I'm just giving you an example. And then how many of you have seen some robotic arms in factories?
I have seen videos of it, sir.
Okay.
So even I saw the video.
Okay. So if you have seen the video, right? So these robotic arms are also like could have been trained hundreds of times in order to go to that precision and then do the work. So someone would have already trained in beforehand. It has to go to this point. Like we do know that coordinates, right? In three dimension X, Y, Z axis. So if you give some point, so that is the from the origin, it is trying to move. Everyone knows cube, right? Cube.
Yeah, so
Okay, so we'll consider that as three axis. In a cube, if I give, if I want to move to the particular point, cube I'll take. Okay, so I'll just say my, just a minute. Let's just say my robotic arm is at the origin over here. So I want to move to some plane. Okay, I'll just give it as a goal over here. This is my goal. So in order to reach there, right? So this robotic arms doesn't have eyes or it doesn't have cameras or something like that. So what it does is like it will try to go into all the points. So it will go over here, go over here, go over here or somewhere. It will try to move to this point. So its robotic arms would be there, right? So it will try to move. At some point, it will go at this point and it will try to touch. So that was the goal which I wanted. So when it's reached, right? So from all the failures it shouldn't go over here. It has to directly go over here. So that is what reinforcement learning in simple terms. This is what I wanted to tell. Okay. Any doubts on this reinforcement learning?
Can you explain this once again?
Okay. For example, this one is your factory, right? So this is your robotic arms. So it has to go and weld at some point over here. Okay. And then, for example, it doesn't know the path where it has to reach over here. So what they do in beforehand is like, if it wants to learn on its own, uh, let's just say like it will go. So if you consider, I am considering this as 3D space because this cube because it has all three axes, three dimension. So robotic arm can move in all three dimensions. So it will try to first move over here. So was this your goal? Mm, so someone asked me to explain, right? Who was that?
Yes, sir.
Okay, Nitish, and this one was this your goal? Green is my goal, right?
Yeah, yes, sir.
Okay, so that is not my goal. So second time it trace, it moves over here. Is it my goal? No, right? Then third time,
No, no,
fourth
sir.
time,
No, sir.
time,
No, sir.
sixth time.
Partially, it is.
Correct. Okay, partially it is correct. Okay, my seventh time.
Yeah, it's same, sir. Partially, it's.
Okay, so you're partially coming, right? So what made you think that partially?
So because that blue dot is touching the green dot.
Okay, so at the goal it is trying to touch, right? So it tried to
Yes, sir.
land. So first it went over here, third, second, third, and fourth. So it didn't reach its goal. So at one
Ah,
point, it tried to reach nearest to that one, right?
yes, sir.
And then, so fourth, fifth, sixth time, it touched on the goal, but partially. Seventh time, that too partially. Like two times, it tried to touch partially, right? So third time, it will try to give the prediction properly. So that is what reinforcement learning is. So you're trying to learn from your failures.
Yes, sir.
So this is about different types of methods. So like based on your data set, based on your problem statement, you'll use different methods and you'll try to classify. For example, so whenever you're having very less small data set, when I told temperature or something like that, right? So there will be less sense of trying to understand from the data is very less. So that time you'll try to use regression, KNN, the statistical methods. So whenever small data, try to use statistical uh, methods. So using that methods, you can try to solve. So when you need something like in order to classify with some mathematical and numerical data, try to use decision tree regression or those kind of things. Then if you come to your images, right? So try to use CNN. Uh, transfer learning also is method of CNN. So example, ResNet, VGG, GoogleNet, those kind of thing use. So OpenCV, how many of you have used?
Sir, I have used.
Okay. So OpenCV also, those and all uses CNN models itself. So if you're going for image, go for CNN models. If you're using time series data, LSTM models, because it's sequential. Once again, based on time, these data are continuous. So you can use LSTMs, temporal CNNs and all. So if you're having very large number of data, I gave you that sensor one, right? So there will be hundreds of sensors. So that time what you need to do is like you have to use neural networks, gradient boosting and random forest. If you use that way, so prediction will be better. And then if you're using text data, LSTM and RNN if you can use, that time it would be helpful. Okay, in RNN, I forgot to tell you one thing. So if there is some sentence, right? So how do you make sense of a sentence? Okay, can anyone read this sentence?
So can I
Yeah, sure.
start simple, linear or logistic regression, then increase complexity if needed. Always validate with cross validation.
Okay, so what if I give only start, then simple, then increase? So this is linear, right? So I'll just give the input, I'll just give the output. Start once it went, simple one, then increase. So it doesn't make sense, right? So what RNN and LSTM and those other things does is like it will retain this start, then simple. So it will become start simple. So that is how RNN works, RNN LSTMs. So that is how your chat GPT tries to understand. So hope like it made sense now. RNN, that memory thing.
So can you repeat again?
Okay. So this one only I take. Okay. So you read this sentence, right? So if I give only start for the neural network, so then output will come something. Output will come. So then if I give simple, output will come. Something it will try to predict or classify or something like that. Then if I give these things, so will this make any sense for you to read?
Oh, no, sir.
Okay. So what RNN does is like, it will try to, when you send start first, it will retain that one. Then when you send simple, it will retain. So it will become start simple. So instead of only start, and it will try to give output, simple output. So start simple. So you understood, right? So if I give just only start, what to start, you don't understand. When to start or something like that, you'll have different questions. So start simple. You're retaining some data and you're passing it together. So any doubts on today's session? Already took 5 minutes more. So just try to understand. So different problems has different solution, right? So don't fit everything into one group or bag. Don't put everything into one grab and one bag and try to do the things. So sort it out. Try to find the solution in different way and use these different models. Sorry, not different models, different methods. Try to solve it for your own problems. Okay, any questions?
So can you share this PPT in the group?
It's already shared. It's shared, right? Yeah, it's shared. Have any doubts? You can ask.
So, like, not about today's session, but like you told me
Okay.
to share with you.
Okay, I told
Maybe.
I'll just give you that this one, right? I didn't work on that one. Today I won't forget. I'll work on that one and I'll give you the output.
Yes, sir.
Because after I gave I had some work. I was completely busy. Sorry. I'll do that one today and I won't forget.
Yes, sir.
Okay, sure.
So, also, like, could you share a video on how like AI answers the question, like you did for image generation? Like the explanation of how AI works behind.
Okay, for image, how I shared that CNN, those kind of things you wanted for LLMs, like large language models, right? So
Yes,
ChatGPT or something like that. Okay, I'll share.
yes.
So I'll do one thing. Text, images. Uh, what are different types of data is there?
You mean like for numericals as well?
Not numerical, like where you find it interesting. Because I can send you like a number of videos, but you have to find it interesting. Like you asked, wanted to understand text, right? So you asked me. So if you want to understand more, like I wanted to get to know your interest, like what you wanted to learn. So based on that, I'll send you. So it's not for Tanishka, for everyone you can ask. Like just look into some solution where it can be easier for you to understand, and I'll just share it with you. Okay then. If you don't have any doubts, we'll end this one in this session. Thank you, everyone.
Thank
Thank
you.
you.
Thank you, sir.
Thank you.